Thank you.
So far, it's good. Okay. So we should get started. I'll just start the live stream. All right, there we go. All right, so this is our fourth episode of Women in Systems podcast series, where we invite researchers in systems and ask them about their experiences in research or teaching. How did they choose what made them interested in the research topics that they work on? And today we have Professor Klimovic from ETH Zurich. She's part of the ETH Systems Group, where she leads the Efficient Architectures and Systems Lab. Her research spans from storage systems, serverless compute, and ML systems. Before she joined ETH, she worked as a research scientist at Google Brain for a year. Before that, she got a PhD from Stanford University, and she completed her undergraduate from University of Toronto. So welcome, Professor Klimovic.
Thanks a lot for having me. You can call me Anna. Yeah. Thanks a lot for having me.
All right. So thank you for joining us today. We would like to get started. We would like to know your general area of research and how do you decide a research topic generally, or what are your hobbies, for example?
Sure. Okay. Yeah, so I mean, my general area of research is in cloud computing and computer systems for cloud computing. So I'm really interested in how we can optimize performance and resource or cost efficiency of running applications in the cloud, how we can make it easy for users to go from writing programs that can run on their laptop to distributing them to many resources in the cloud without having to worry about distributed resource management. So this is where the area of serverless computing and kind of new abstractions and execution and programming models for the cloud I find super interesting. And the time that I spent, so my PhD work was mostly on storage systems in the context of cloud computing. I looked a lot at resource disaggregation and how we can, by splitting compute and storage, how we can, without sacrificing performance too much, how that helps us get better flexibility in how we allocate resources and customize them to different applications. And then the time that I spent at Google Brain before joining ETH as an assistant professor, I was surrounded kind of by ML researchers and systems for ML researchers. So this is kind of a time when I got to apply some of the things about storage systems in a context of machine learning applications and what are their system requirements. So that's kind of become another area of applications, or another area of research that I'm very interested in, how to build efficient systems for ML applications. And this is a lot of what people are running in the cloud as well, or at least many of the kind of large scale, expensive workloads are, and how we can make that more efficient.
Yeah, that is pretty interesting. So before we get into the list of questions that we have, is there so I guess let's just start with the question. So so you worked in industry for a year, and then you were a professor since 2020 at ETH. How do you compare your experiences in industry at Google Brain and so far at ETH, or during your PhD working in academia? How does your experience compare? And is there anything that you find interesting?
Yeah, I mean, I enjoy both experiences. I think the types of tasks you do day to day do vary. In industry, I mean, I think there was a lot more time spent on actual implementation of systems and stuff, or I had time to do that kind of thing. Leading a research group as faculty tends to be more on the advising and making, guiding students in their path in research, but a lot of the implementation work is done by the students themselves. And as a PhD student, I guess there was also definitely a lot of implementation work. One of the things that kind of struck me when I was doing the work in industry at Google, it was part of, it really depends, of course, which research position you're talking about, which company and which context and so on. There are places where you can be in an industry research lab that has a lot more similarities with academia than maybe being in a product team. But one thing in Google research that I enjoyed was seeing kind of much larger groups of people working towards a common vision, whereas I think in academia, the teams are not necessarily always that large. There's kind of a lead PhD student usually on a project, maybe collaborating with a few other students. But in at least what I saw at Google was there were, sometimes 20 people working together on a common goal. Yes, there's like sub projects within that, but the kind of combining the large size of, experienced researchers working on a topic plus lots of computing resources meant very ambitious visions for research projects. So I thought that was really exciting. And then I think in academia, what I really enjoy is kind of constant interaction with students and the combination of doing research, but also kind of mentoring and teaching and so on. I find that really interesting, really rewarding. And I end up working on kind of a lot more projects at once. I think you could have a mix of this as well, depending on your preferences. There's potential to do this in industry too, but definitely at least comparing my experience at ETH so far, or at least especially at this point, kind of 2 years in compared to at Google, I was kind of working on 2 projects at a time. And here, I have now 4 PhD students and several master students and so on. So there's kind of more multiplexing between research projects and stuff, which is interesting. And then maybe the other thing I'll say is just, so depending on, if you're an industry and a product team, I guess there's a lot of potential to have impact in the company or impact on the product and see what you're doing, maybe eventually make it to users, which can be very rewarding. And I think in academia, you're sort of focusing on, I think your impact is on the field and, you're publishing papers and you're kind of sharing your knowledge with the community. And I think your impact is also on the students that you mentor and et cetera. So I think there's, to some extent, a mix of these across both, but that's maybe another differentiator.
I see. So something that you mentioned is like the team size varies pretty, it's a big difference. In industry, you have like pretty large teams working on a single product. Do you think that affects like the projects you can choose in academia because you can have only so many graduate students working on something? Or do you think like it's mostly engineering effort that needs large teams in industry, and so you can like do comparable like in terms of research project size, you can do comparable research in academia?
I think it's something that needs to be taken into account to some degree. It can impact the kinds of projects you choose. I think there's still a lot of really interesting projects you can do, and PhD students can actually really get a lot done. And you also don't have to build everything from scratch. You can build on, there's a lot, thankfully, I think more and more culture of open source frameworks and, being able to build on prior work, so that lowers a bit the barrier to entry there. I guess another consideration, especially on these ML workloads, if you need many GPU or TPU hours, et cetera. But thankfully, there's also pretty good grants from companies and so on to support research. So that's also like something that we've been fortunate to have. And so overall, I haven't felt constrained by kind of the types of projects. But at the same time, I am cautious to not pick something that, has where to get to the research question requires too much engineering effort.
I see. So like in general, it would I guess it would be nice to have like a big team in academia, but
First, I think it depends on the topic. I think for computer systems, it's good to have a team. And in general, what I in my group so far have been encouraging, and I think I've seen that in the PhD as well, in my own PhD, is that it's very helpful to have collaborations. And so either students working together and or in combination with some collaborations in industry as well. Or maybe, for example, doing an internship where you get to spend some time in an environment that has a bunch of infrastructure implemented, and you can explore a research question. You can get a sense of what are some interesting workloads, for example, what are some real problems that arise at scale. And then we can find some way to have a platform that we can explore and continue exploring some of those directions in from academia. And yeah, that works best, if the code happens to be open source. If not, there's often ways you can still sort of figure out some open source equivalent or build something that will allow you at least to explore the higher order bits of the research question.
I see. So going on a tangent here, you mentioned industry internships. So do you think it's good for PhD students to, during the start of their program, go on internship and like see, because a lot of these students directly join from undergraduate, like at least in the US, that's the trend. Do you think it's good to do industry internships in the start of their program and like get an idea of like what topics or like people are looking into?
Yeah. So again, I think it depends on the type of internship because they're not all the same, but a research internship, and especially if it's one, I think, I in general found them very useful. I did 2 research internships during my PhD, and I had come to the PhD kind of, straight from undergrad. So for me, it was really helpful. I spent my first summer after my first year at Facebook, or I guess now Meta, and the other summer at Microsoft Research in Cambridge, UK. And both of these were, very different experiences, but really, really helpful. Actually, the Facebook internship is kind of what kickstarted this theme of research disaggregation that ended up becoming the main theme of my thesis. And that kind of, started with things I had learned or problems I saw or kind of trends I saw happening in the context of that internship. So I definitely think it can be helpful. I think it works best when the internship is set up with kind of maybe your advisor already knows the internship mentor, perhaps, or there's some sort of joint interest. Maybe you have read a lot of papers from that particular internship mentor or that group that they're part of, or something where you have kind of, you expect that probably the things you'll be working on. Sometimes you actually don't know exactly what your project will be. Maybe they can't share all the details before you join, or internship hiring happens like 6 or 7 months before the actual internship, and it's not yet clearly scoped what you'll actually work on. But if there's some sort of clear mutual interest in the topic and something that you expect you can actually build on, or in some way use it to complement your PhD work, I think that can be really, really helpful. And it could, in early stages of the PhD, I think it's a great way to get inspired for real problems and measure them in a practical, real setting. And even if you don't build a solution, publishing something that says, or at least learning for yourself, but even better if you can publish kind of a motivation study that later becomes, what you cite to say, this is a real problem. And now now that you're back doing your PhD in academia, you show how you might solve it. And another type of internship, perhaps for later on in the PhD, is you've built something and you would love to actually see how well this works in a practical scenario. And you find, a setting in an industry and in a company where they have some interest in trying out the technique, but of course it would be quite difficult for their own engineers to find time to do it. So maybe you do an internship and actually on some level implement some of the ideas of your system into their practice. I think that can also be really rewarding, really informative. You might find new issues that arise. And it's also just great to be able to say that, the ideas that you've used can be applied somewhere.
Yeah, that's a very good point. Like when you start, you can get a glimpse into what the impact can be of the research areas that you're exploring. And later you can actually, if you built something, you can see how it actually performs in production environment or in deployment. That is pretty interesting. So moving on to the next question. So you did your PhD at Stanford and your undergraduate in University of Toronto, and then now you're a professor at ETH. So you have like experience with academia in these three countries. Is there anything that stood out to you in terms of like the differences, or anything that you found interesting around this?
Yeah, it is interesting to think about kind of different contexts, I guess, both on general education side and also research side. I would say in research, things operate actually quite similar. I mean, again, actually, I can't speak for Switzerland or Europe in general, but at ETH and especially in the systems group and so on, the kind of research environment is very reminiscent of what I saw at Stanford. Lots of ambitious research projects and really great students and postdocs and everything, really great colleagues, and lots of talks from industry, lots of collaborations with industry. I think at Stanford that was even more natural because Silicon Valley is right there, and you're just it was kind of even more natural here. Sometimes it translates into calls with 9-hour time difference and so on, but we still collaborate quite a lot with industry, and some also more local industry, but also a lot with people on the West Coast. And so research-wise, I would actually say that there's a lot of similarities. On the education side, there's some differences. So one thing in the North American system is I feel it's quite common for students to get more choice in their undergraduate program to pick what they want to study. Like you might have, you might be undeclared, or there's some sort of program you can sign up for where you're taking a bunch of courses, but you don't quite have to commit to the ultimate degree you'll get until maybe 1, 2, maybe even 3 years in. Whereas at least at ETH, you enroll in a particular department, and you do that kind of from high school to undergrad. So I think that's one thing where there's not quite as much shopping around in the beginning, and maybe that influences sort of which directions people tend to go in. I'm not sure, but one thing that's really nice here is that education is essentially nearly free, and it's actually open to everyone. So there's no entrance exam. It is, if everyone who all Swiss people are eligible to study at ETH, and there's no entrance exam. There is a hard set of exams after the first year, and not everyone makes it through those, but it's sort of like everyone has a chance, and so I think that's also interesting and quite different from the system in North America.
Yeah, that is pretty interesting. So in terms of like research environment, do you think like as a prospective student, for example, like a PhD student, or like someone who's applying for PhD programs, do you think like there's differences between, I guess, Switzerland and the US that they should consider while applying? One thing that I think is like in ETH, you have to be a master's student to apply for PhD program. Like you should have a master's degree.
There is, so in computer science, there actually is the program called direct doctorate, which was kind of designed to address that, it's actually in North America quite common to apply from undergrad. So there is that option, but even in that program, the way it's designed right now, at least it does basically involve sort of getting your master's along the way, but you can apply and can be admitted and have kind of a guaranteed path to the PhD, even from undergrad. So that's the direct doctorate that I think, at least it definitely exists for the CS department. I'm actually not sure that other departments have it at the moment. But generally, there's quite a bit, the kind of standard path is after a master's degree. And I think this just comes from the way it typically works in European institutions, that there's sort of, the bachelor degree is not necessarily, it's a 3-year degree usually, and non-terminating, most people just go and do the master's. So that's sort of the natural path. But we do have this direct doctorate. And in terms of, I don't know, I mean, sure, there's geographical preference, in terms of just what you personally prefer where to live. I actually think Switzerland has been a really great place to live. I've been very happy here, but I mean, that's definitely a personal thing. And I think it's just really important to pick an advisor that you really can see yourself working with, that you feel you would have a good relation with, and kind of a group that you feel will be supportive and is doing like interesting topics that seem interesting to you. I think the actual project you'll work on, even if you discuss it sort of, ahead of having accepted an offer or so on, it might change, it's research, it's sort of, things are unpredictable. And by the time you actually start the position, things might have evolved. So I wouldn't get too attached to a particular project you discuss. But I think in general, to just the group and the advisor, I think this is really, really important. And yeah, big influence of like what your day-to-day will be like as a PhD student.
Yeah, that's a really important point. Is there like anything that you would recommend like prospective PhD students to do, or like ask their potential advisors to get an idea of like of how that like the PhD life would be, or like how the research as a PhD would be?
I think it's really helpful to try and talk to students in the group. So I guess this is, especially when you have I guess there's sort of things you can do to even decide, do you want to apply for a PhD and do you want to apply in that place and so on. But I'm assuming your question is more on the other side of like deciding where to go for your PhD and what you can do to prepare if you have a position coming up and so on. Is that right?
Right. Yeah.
Okay. So I think it's really helpful to chat with other students in the group, and just especially in the like decision-making process or whatever. I think, students who are currently there probably had also some decisions to make, and hearing, their thought process and also how they enjoy it there and so on. I think people will generally be honest, and generally that's something I also try to set up for all applicants and so on, so that they get the student perspective, without me being there in that meeting. I think it's nice if you have some in terms of like preparing for the start of a PhD. I think it's good. There's some kind of advice and blogs and so on that I've sort of started collecting a list of. I can also share if you're interested, but there's sort of people, faculty or people who are now industry but have PhDs and have sort of written about their experience. I found some of these kind of interesting to read, and sort of take with a grain of salt, because I think every PhD is different, but there are kind of common themes, and knowing about certain pitfalls and so on, I think can be interesting, though I'm sure sort of it's a little bit hard to imagine when you're just reading this and haven't gone through it yourself yet, but they kind of, maybe you gain more appreciation for some of them when you start to see similar things happening to you. And then, I guess reading a little bit about the general area you expect to be working in could be useful, but I guess I would also strongly recommend taking a proper break, like a vacation before starting, because I think these times between jobs or between programs of study and so on are really great times to kind of reset, relax a bit, and then you're ready to go. You don't want to start your PhD kind of exhausted from whatever previously you were doing. I think It's nice to take a good break and just come in ready, enthusiastic to learn and to dive into projects.
Yeah, that's a pretty good point. I think like breaks are important, and like some things, that's something that you don't realize, that it's also part of like your PhD program, that you should take breaks between projects. Let's see. Yeah, that was pretty helpful advice, and I think the people would be interested in seeing like all those reading those blogs that you mentioned.
Yeah, I can share it. Yeah, they're not written by me. It's like a list of things I have collected, and I'm sort of I guess maybe eventually we'll write something that is anyway.
All right, thank you. So that was like more of your experience as a student and a researcher. So moving on to the second topic of this podcast, which is like, how do you choose your research topics? So something that is interesting to me is like your PhD research was on star systems, but like your research as a professor is more on ML sys. So what was the journey that led you to choose this research topic as like something that you wanted to do as a professor?
So I think for me the evolution was kind of that I spent this 14 months or 1 year around at Google before joining ETH. And for me, this was a really great opportunity to kind of broaden my horizons a bit. You know, in the PhD, you're very focused on your particular research area. You have some outlook on, you know, the surrounding topics and so on. But it was actually very good to be in a group that was much more on the ML side. A lot of systems, great systems colleagues who were working at the intersection of ML, but also like pure ML researchers and going to talks about topics I had not heard of, and just kind of getting up to speed on what were research questions that were interesting in that area. And I tried to sort of navigate in this new space. And I thought, okay, well, one thing I have been working a lot on is storage systems. And I actually didn't see that there was a huge focus on how was storage being designed. I mean, you're training on huge data sets, but we're sort of like retrofitting or just kind of using the existing storage infrastructure. And I also became interested in this, like, it seemed like I was also generally interested in resource efficiency and so on. And it seemed like actually there was a problem of, you know, GPU accelerators, whether it's GPUs, TPUs, et cetera, that there's a potential that you can be having these expensive resources sitting idle if you were not able to ingest data fast enough. So whether it's the reading from storage, or this actually turns out a lot of pre-processing operations you do to the data before you feed it onto the accelerators. And so this kind of naturally led me to this part of ML systems that was more on the data processing, data ingestion side. And that was I spent a lot of the time that I spent at Google doing like a fleet-wide characterization study in collaboration with the TF Data team, and TF Data is the data loading library in TensorFlow. So this was really insightful and helped kind of set a future research agenda. It helped establish collaborations that we're still have today. So some of my students at ETH we've been collaborating with Google on ongoing projects. So that was sort of the story of that. And then once you're kind of in that area of now machine learning for systems, there's all kinds of interesting projects. With some of my other students, we're looking at elasticity in machine learning frameworks, adapting seamlessly to failures, especially if you want to use something like spot instances, which are 60 to 90% cheaper in the cloud, but can be preempted often, so you have to deal with frequent failures. And so, yeah, I think once you sort of peer into a new area and get a bit more comfortable, and it's nice, I think, if you can bring in some expertise from a previous area you've worked in, then that transition feels kind of more natural. And then the other transition that I've kind of been doing over time is into serverless computing. And that kind of started with a project in my PhD, which was a storage system. And we had kind of a fast way of accessing remote, so over the network flash storage. And I was kind of looking for, use cases where this could really be, really shine. And serverless computing was emerging at this time, and actually turned out that there was no way to really assume you have local storage that persists across invocations. You had to go to remote storage, and actually then building a storage system to address those needs got me into serverless computing. And then I also just found it generally really fascinating to like rethink what is the programming model to the cloud, and if the cloud provider now is in charge of resource management, what are all the things they can do to make it more efficient? And so that was sort of my segue into that.
I see. So that is pretty interesting, that getting some industry experience before you started as a professor. Is that something you would recommend like PhD students who are graduating and like who are looking into academic positions? Would you recommend like to them that they should look for a position in academia and then start looking for like sort of a short-term research scientist positions in industry so that they can get an idea of what's going on?
For me, it was really beneficial. I feel like I learned a lot. It was a great kind of perspective. It also gives you a little bit of time in between before you start to kind of bootstrap a few things for the faculty job. So you can usually get access to your academic email address and have set up your website, and then get to access, you have the credentials maybe to access the student hiring and so on, which is kind of the main thing. If you can already participate in the hiring cycle for students who can then start at the same time as you, that's quite helpful. So you don't sort of have this slower start at the beginning. So that's one other advantage, but mostly I think what was super beneficial was just getting the extra perspective, meeting, really great colleagues and seeing what kind of things they're working on, just kind of opening your eyes to all these other problems that you didn't think about as much because you were focused on your PhD problem. So I think it's really good and I think it doesn't necessarily have to be industry. I think just kind of changing environments is really helpful. And certainly, I mean, if you start an academic position, you're probably also changing environments. But I guess this is kind of just an additional leap in between, which can also be very useful.
I see. So do you think like it is helpful to network? Like when you start as a professor, I would imagine it would get harder to network in industry and collaborate unless you're like visiting industry as a researcher or applying for grants.
What do you mean by harder to network than compared to
like when you are actually in industry, like before you start as a professor, or like if you're visiting industry, I would imagine like it would be easier to network with people in industry and collaborate and like build relationships.
Okay, I mean, I guess to just reach out to someone who's in the company is super easy if you're in the company, and you can just or I mean, depends on the company, I guess. But if it's open culture, then sure, it was very natural to just reach out to people. But I think knowing a few key people that you've worked with or that you kind of know what they work on still works well to just reach out. If I'm curious about something, I can reach out to them and say, do you know who's a good person to ask, and they can connect you with them. So I think that's been fine. And actually, I would say I get to network a lot, if not more, because it's not just within one company, but across many. And we have talks from industry guests and from other universities, et cetera. So and when someone comes and gives a talk, usually we set up some meetings after. So and there's sometimes follow-ups from that. So I do feel like actually maybe even more chances for networking. I mean, part of the year I spent at Google was also during COVID. So that was, of course, limiting in the networking and meeting people side. But it was good that when I started, I was there in person, and that was super helpful. And I met a lot of great people. So it's been good.
I see. Yeah. So moving on to like more of your more towards the research in serverless compute. What do you think about like serverless compute's future? Do you think there are like areas there where serverless compute can change the way compute is done in cloud? What are some of its limitations and like strengths that you think are like helpful?
Yeah, I think it's a really interesting question, and I mean, definitely something I think about. I think serverless is still in its early days, and it's yet to be seen sort of how things will evolve. But I think this idea of raising the level of abstraction for users so that a user doesn't need to be a computer systems expert who understands how much memory, CPU, network bandwidth they need for their application. I think, raising that level of abstraction so users just say, here's what I want to run, here's when it needs to run, please figure out how to run this efficiently for me. I think that general idea makes a lot of sense, and I think that is there to stay. And I think serverless, it means many different things. Often it's kind of most connected to functions as a service types of platforms, but there's also all kinds of X as a service, right? Like ML as a service, where again, it's sort of raising the level of abstraction that the user doesn't have to actually spin up the machines, run the actual model, but instead can just query the service. And so I think the general trend in cloud computing is moving more and more towards these sort of services that users can query, that they can submit their code to or submit their queries to. And then it's kind of, I think there's really interesting questions about what should be the programming model, how to compose, how should these services communicate efficiently with each other, and make it easy for users to write applications that use these things, but also to do things in a actually fast and resource efficient way. So things like these current limitations in serverless, where you have to communicate between two different functions, because we're not supposed to have a notion of which servers they're on. Or actually, this may be one reason why current platforms don't actually, by default, allow functions to communicate directly with each other. And so every kind of actual communication of state is done through some remote storage system. I think these are some things that will likely change over time because it's not a data efficient it's not an efficient way, energy efficient way of doing things, and it has performance implications as well. But I think it's a really like young and exciting area, because I'm not sure that AWS anticipated what everyone would start using Lambda for. And so I think that's also been really interesting to see. And sometimes I think things are released to see, is this a useful programming model and use case for users? And then later comes the question of how do we actually build this in a performant way and a scalable way. So I think, I definitely think this abstraction, higher level of abstraction to the cloud makes a lot of sense. But I think we'll probably still see some changes, evolution in the programming model and the actual underlying implementation of things, and the kind of lifting of somewhat currently artificial limitations like the execution time. And there's already been a lot of changes to this in the past few years, like the size of the executable you can have and the runtime and things like that. So it's rapidly evolving.
I see. So so for serverless computing, do you think like there are areas where it could create a big impact, considering like it's still in its early stages and there's performance implications, and when you like general what people expect is like when you go higher in the abstraction layer, you add more overhead. So do you think like there are areas where this can help a lot, or and if there are other areas where this can potentially help, but like because of the performance implication, some of these, like for example, communicating between different functions?
Right. Yeah, it's an interesting question. So I think there's still opportunities to actually eventually help with performance. I hope. One reason I think this is, okay, you're raising the level of abstraction. I mean, so if you're adding more and more layers to do that, then sure that, each layer comes with its overhead. But one thing that is also happening here is we're kind of shifting who is responsible for what. So instead of the user being responsible for resource allocation, it's now the cloud provider. And presumably the cloud provider, the user knows more about their application, but the cloud provider knows more about, what is the actual resource usage in the cloud at this moment, in the clusters that are available. It can sort of track invocations across, it can track invocations across functions, across users, et cetera. So I do think there's a lot of information or just expertise that the cloud provider has. And even if they don't know the actual internals of the application, I do believe there's a lot of interesting things we can do as systems programmers to try and implement resource efficient, management of these kinds of applications. Because I don't think that users necessarily make the right choice. And I think even experienced users who think about this, it's just really not easy to know what your application needs. But perhaps the cloud provider can sort of dynamically adjust
I see. So I guess like one advantage here is that the cloud provider has like a global view, like what's going on in the data center, or functions around.
Global view, and like this is their business managing these resources. Just kind of more experience with these types of problems.
I see. And in terms of like the overheads, do you think like there, or like in your opinion, what are the important problems? I guess like one of the problems is like communication between functions, right? That's really expensive right now, even if they're co-located on like the same machine. Do you think like there are other problems, or like this is one of the most important problem in like serverless compute?
Yeah, I think another related thing is sort of what is the right programming model? Is it this relates a little bit to these restrictions in networking, or just like how to, if you want to enable networking, how should you do it? You still want to sort of avoid having any notion of physical servers that the users need to worry about behind the scenes. And not just related to networking when I say programming model, but just in general, how to compose more sophisticated applications that need, have some kind of state associated with them as well, and need to coordinate amongst multiple workers, and how should this kind of be expressed, and how can it be intuitive for users? I think one of the big things about serverless is that it is easy to use, but it is also limited in what use cases it's designed for. And if you go beyond those, then you sort of run into a bit more complexity in how you're going to do that. So I think there's still a lot of questions about what's the right programming model for mapping even just, what runs today off the shelf on regular VMs to how you would run it in serverless.
Right.
And then I think there's also still a lot of room for improvement in just the system stack itself. Like we're sort of, the whole infrastructure for running serverless is based on retrofitting the stack for virtual machines, which were designed, a long time ago with very different assumptions of what kind of workloads are running. Whereas serverless functions tend to be quite small in their resource footprint, quite short-lived in their execution. And so, do we use virtual machines because we run each function, or cloud providers will run each function typically in a separate virtual machine or some kind of secure container. And this is for secure isolation, but are there other primitives we can use? Can we leverage advances in CPU hardware, security features, et cetera? Can we rethink sort of how we design the system stack to remove kind of this software bloat that has been accumulating, and that I guess the current approach has sort of been retrofitting and trying to slim down those layers. But I think there's also opportunities to sort of step back and rethink what that system stack should look like, knowing what workloads look like today and what hardware you actually are building on top of today as well. So I think there's a lot of kind of interesting questions there, and kind of what is the per worker OS or system stack that runs, and then also the cluster management that needs to handle all these things across multiple nodes and handle many, millions of indications per second. And yeah, so I guess a lot of interesting questions, I think.
I see. Yeah, that was pretty interesting discussion, what the challenges are currently and where we are with relation to serverless compute. And since we're heading towards the end of the podcast, I'll move on to the last topic, which is managing relationships as a PhD student. How do you talk to what do you talk? What's the most important thing that you should talk to your advisor about, related to making the most out of your PhD? So actually, that's the first question. As a PhD student, is there anything that you would recommend as a PhD student someone should do to make most out of this advisor-advisee relationship, in terms of research or deciding career stuff, or anything that you would recommend?
Yeah, I mean, I would say don't be shy to ask questions or ask directly for advice on something when you're not sure. I mean, your advisor can't read your mind. So if you're not sure about something, it's or you're wondering if you're doing a good job at something or if you should be thinking about something else, I think it's good to just ask. I also think it's really helpful to have a good relationship and be close with other teammates in the group. And you can also ask senior students for advice. I think it's just good to everyone is different and has different strengths, and your advisor might be most, it's good to pay attention to what kind of things can your advisor help you most with, and what kind of things are they the type that's going to sit down with you and look at some part of the code. That might be the case. That's maybe often not the case because, they're not operating at that quite level of abstraction for each research project. But maybe they help you a lot with kind of navigating the high level research vision, helping you sort of see the connections between different aspects of a project you might be working on. And then, if you find you do need some help with implementation stuff, maybe you can, ask if it's appropriate to start collaborating with someone, maybe just because you're stuck on something, but, or you notice that it would be very helpful if, there's just a lot of work to be done and it would make sense to collaborate, or maybe you want another perspective and you can get that from industry. So I would just sort of say, pay attention to what things your advisor can help you most with, and what things maybe you should also kind of find some other sense of support system from. And also see sort of what things, actually, I think what's really important is to make sure expectations are clear. So if you have any questions on what are the, I think it's a very important thing to discuss, and hopefully it's something that the advisor brings up, but I think it's also otherwise really appropriate to ask sort of what are the expectations? Are you meeting them? Is there something you can do to improve? And so yeah, I think just like communication with your advisor is important, and not being afraid to, yeah, ask questions. If you think having an additional meeting would help, just ask for it, and see how it goes.
I see. Yeah, that's a pretty important point. And that also brings us to like our next question, which is like, how should a PhD student ask their advisor about, well, like sort of a performance evaluation? Like, should you do it like pretty often, or how do you expect your students to do it, I guess?
Yeah, I've been thinking about this a lot recently. I was taking actually a course at ETH for faculty about like an optional thing we can take. And one of the things we discussed was sort of how to do feedback and so on. So one thing I've been kind of experimenting with in the past, couple of years that I'm here, is doing like an annual, just setting aside a meeting that is purposely, we set aside an hour, or maybe we can discuss for longer if necessary, but it's just a meeting intended for stepping back and discussing what's going well, what can be improved. And it's not about the project, because that's what we talk about mostly in the regular meetings, but it's really a chance to kind of a temperature check, how are things going from each perspective. And also it's an opportunity to talk about the students' career goals, and just sort of thinking, aside from just the project they're working on, how to put this in the context of their greater goals, and how to set goals toward, how to make sure that they're on the path towards achieving that. So this was, I think, I found it super helpful. What I did to organize these meetings was put together like a short list of questions to reflect on before the meeting. And the questions were basically like, what is going well with the project or with your skill building and development? What can be improved? And then there's sort of like how happy are you in general with the PhD experience so far, just to kind of, on a scale of 1 to 10, and, what could help improve that? And then, what are your career goals? And then what is feedback for me? Because that was also important to me to sort of, if there was something that from their perspective could help a lot and could be done differently. And then I would also share feedback with them on how I thought they were doing, what I thought they could pay attention to as further areas of improvement. And I think from both sides, this was kind of a beneficial thing. And I think it doesn't have to be something that you like have on a very strict schedule, like in a company with these performance reviews. But I think it's nice to maybe at least set a reminder in the calendar to say like, okay, we should have this at some point, and maybe there's kind of more natural times to have it and not maybe when you finish a project or something like that, or you're about to start a new one. But I guess this works more naturally when it's the advisor who proposes it. But I mean, if you think as a student this would be super helpful, I think you should always feel free to ask for feedback. And you can, if there's specific things you would like feedback on, formulate, those more specific questions as well. And I think advisors should be, happy to have that conversation.
I see. And in addition to that, do you think like there are questions that PhD students should ask themselves, like to evaluate their progress, like as they go through the program?
Yeah. I think it's important to ask yourself, is the problem that you're working on really important? I think this is something that, you ideally want to convince yourself of before you start, but things, the landscape might be changing a lot. There might be, some type of technology was discontinued, or a new technology has emerged, or, just the landscape is really changing very, very rapidly. And it can kind of influence how people will perceive your work, or sort of, how relevant is it, is the particular problem you're focusing on. And so I think it's good to sort of reevaluate that periodically, because you can be putting in as much effort as you want, but ideally you do it through towards a focused problem that is well motivated. And I think before embarking on a research project, I think it's really important to kind of measure the problem. This is something that my advisor always used to say, and I found it really helpful, as like, there's going to be some baseline you need to compare to anyway, and you might as well really get familiar with what are the problems that arise when you use that baseline today, and start with, really understanding that, defining the problem, and then you can start building your solution. So yeah, I think in terms of like the research project, those are some things I would ask. And then, yeah, I think it's good to write kind of yearly or whatever frequency you want, like actually write down goals and then, go back to them at that time and say, am I achieving what I've been setting goals for, or am I behind on that, and why, and what could be done better? Yeah, I guess those
I
would be some
see.
of the things. And then just think about the skills that you want to build, or, what kind of career path you want to pursue eventually. And there could be, things outside of the research world that you want to take advantage of while you're at the university. There's also really interesting kinds of classes that you can take that might not be super related to your research, but can be just good for life skills. At Stanford, we had like a design thinking course, a public speaking class. These were all really interesting to take. And it was sort of a unique opportunity to do that on campus.
I see. So I guess like for PhD students, it's helpful to once in a while think about like how their progress so far, how their research projects align with their career goals, or like what they want to do after their PhD.
Mm-hmm. Yeah.
Yep. So moving on, do you think like how to whether a PhD student like during the PhD should have mentors other than their advisors, and if you think that's helpful, like how should they choose their mentors, like to get advice, and like what kind of advice should PhD students seek? Because you would the assumption is that most of the research related advice would come from your advisor. But like for other stuff, what would you recommend? Like who students should talk to?
I mean, even for I think it's quite, and so there's kind of different types of mentors, I guess. So I remember during my PhD at Stanford, we had several types of sort of mentorship programs you could sign up for. You get automatically matched with someone, and so you're not really picking your mentor necessarily, but sort of assigned, and then you meet up for coffee every so often. And those were good. I think for me, it was, I think just talking to people in general, I feel like you always learn something and you hear a new perspective, and it's super useful. I think the kind of most valuable mentorship has been, I kind of think it just evolves organically. Like, I think it's good to just talk to a lot of people about their experience in the PhD program. I think it's actually quite shocking how much similarity there is across like experiences people go through in their PhD. If your advisor is going on sabbatical and you're just started and you have no idea what you'll do, there is probably someone who had that exact same situation, or like, I think there's a lot of similarity, and things might happen at different times in the PhD, but I think there's a lot of like common experiences that you can learn from other PhD students. Sometimes you have like an official co-advisor or some kind of mentor assigned to you, and I think it's definitely good to reach out to that mentor and so on, and stay in touch with them. But you can sort of see what is the kind of advice you're getting from whoever it is you're talking to, and for the people, take all of it with a grain of salt. I think, especially if you're talking to a lot of people and getting, hearing a lot of different perspectives, they don't necessarily all align. And I think there's not just like one way to be successful, or, there's not even one definition of it. So I think you got to adapt things to your own setting. And for those people that you notice, you feel like you connect most with their, insights or advice that you've given, maybe those are the ones that you tend to meet more often with. And I guess with mentors, like, I think it's good to, really treat it as some kind of relationship, that it's not someone you just go to when you have problems, right? But maybe it's also someone that you share some happy news of some milestone that, you had talked with them about before, and, your paper got accepted and you gave your first talk, and you want to thank them for, to make sure to also sort of go in that direction, as opposed to whenever, they're going to get an email from you, it's because there's some sort of, something that is some problem that you want to solve. So I think it's good to sort of just treat it as, you're kind of building a relationship over time, and it can eventually kind of go back and forth, I guess.
I see. That is pretty interesting. And that brings us to the end of this podcast. Thank you so much for taking out time. I know it's pretty late or there. Thank you again for
thanks a lot for organizing. I think it's really great that you're doing this. And
thank you.